Hey guys, so today we're going to be talking about how these tropical cyclones begin to form. So yesterday you should have discovered kind of what a tropical storm is and kind of the different names that it can go off of. And today we're going to talk about how they're created. So there are three stages that happen in this formation process. So the first stage is formation stage, second is mature, and the last one is dissipation. So if you notice that the first two stages have these kind of subcategories that storms can be classified as. So in the formation stage, once this storm begins to create itself, it can go into what's called a tropical depression category. So depending on the wind speed that is happening, it can be classified as a tropical depression. And that's just the name of the storm. Whereas in the mature stage, you can have two categories. You can have what's called a tropical storm, or you can have a tropical cyclone. Now remember, a tropical cyclone can also be classified as a hurricane, typhoon, or just a regular cyclone. We're going to talk about what kind of creates these differences in these types of storms and how you can memorize them. So in the formation stage, you have just the beginning process of creating clouds, right, above these oceans. So warm air rises above the oceans, and if you remember from yesterday, we talked that this water has to be 80 degrees Fahrenheit or hotter in order to create these huge storms. So we know that when clouds begin to form, we produce latent heat. Remember, latent heat is the energy that is either absorbed or produced during a change in state of matter. So when your water vapor, your gas that is in the air, goes into liquid water when the cloud begins to form, latent heat is produced, meaning that it's giving energy to the surrounding air mass that is ultimately giving the energy needed to create these huge storm clouds. So this rise from these air masses are lifted from the water because of a weather disturbance. We talked about yesterday what a weather disturbance is, and just a reminder, it's typically either a smaller storm or a gust of wind from the coast that happens. This rising air helps create a lower pressure system. So if you remember, previously we have talked about pressure systems. We had a high pressure system and a low pressure system. We know that low pressure system is associated with rising air. So during this formation stage, you start to create a low pressure system. Warm air from the outer edges begin to move towards the center. So on the outer edges of, you can see where those red arrows are, you're going to start moving in closer to the lower pressure area. Remember, we always go from high pressure to low pressure, and then it goes up into the sky to create your clouds. And the Coriolis effect gives this moving air a spin. So it's not just moving straight, it's more moving on an angle. As you can see, those arrows are curved, and that's due to the Coriolis effect. So you're going to watch a video at the end of this to kind of help you remind you, or you should have watched it yesterday, sorry, yeah. You watched it yesterday to kind of help you understand what the Coriolis effect is again. So where this becomes a tropical depression during this formation stage is when you have wind speeds that are less than either 62 kilometers per hour or that's 39 miles per hour. So when the winds are like this, we call this a tropical depression. And that's just the same thing as saying like a rainstorm or a tornado. It's just the name of the storm that is happening. During the mature stage, you have air that is moving in and up, right? So it's going from the outside into the center and then up. It starts to begin to pick up speed. And this creates what's called the eye of the storm. So that low pressure center is your eye of the storm. And this is an area where there's actually clear blue skies. So once the tropical cyclone begins to form, this area actually has no clouds and there's actually no rain, and it typically is very sunny, and there's a quick opening of this. However, surrounding this eye is what we call the eye wall. Around this eye wall are where the strongest of the entire storm's winds occur. They have the densest clouds, and they're all surrounding the eye. So this is very important to meteorologists who are tracking the storms because they can kind of see when the most damage is going to occur. If we know where the center of the eye or center of the storm is, right, the eye, we can then know that the outer edges of that eye, when they pass over a city, that's when the most destruction is going to occur. Now, the storm that was originally a tropical depression now goes into what's called a tropical storm. And this is when the wind speeds accelerate into more than 62 kilometers per hour or more than 39 miles per hour. Once it actually becomes classified as a tropical cyclone, again, that's another name for your hurricane, cyclone, or typhoon, is when the wind speeds are going to be higher than 119 kilometers per hour, or that's 74 miles per hour. So scientists have kind of classified these numbers because I know they do seem kind of weird and kind of uneven. And the reason why they classify this is based on destruction, okay? And when a cyclone, a tropical cyclone or hurricane really becomes detrimental to people and structures and things like that. And they've found that happens at 119 or 74 wind speeds. So your tropical cyclones, again, are a part of your mature stage. There are three names for them. They're either hurricane, typhoon, and cyclone. And those, again, are because of where they are located in the world. So it's a cultural thing based on where they have formed and moved to. So within this either hurricane, typhoon, cyclone, whatever you want to call it, are these rain bands. So you can see them kind of labeled on the diagram there, and they're just pockets of clouds creating very, very heavy rain that you can see there in the picture. Have the dissipating stage. So this is when the storm begins to clear out and go away. So this happens when there's no more wood to fuel the fire, if you want to call it. So this is really when the storm cannot produce enough energy to sustain itself. So typically this happens over land or colder water. So we know that where the storm gets its energy from is the outside of the edges of the storm, right? Because it's moving from the outside to high pressure to the inside lower pressure, eventually rising, creating thicker and denser clouds. Well, if the energy source from the outside of the storm can no longer be fueled into the center, the storm begins to dissipate, meaning clear out. So we know that this happens over land because we know that a hurricane, cyclone, typhoon, whatever you want to call it, needs our warm, moist air. So if it is over land, it's missing the moist component, and if it's over colder water, that means it's missing the warm heat aspect of it. One of the main damages that can come from hurricanes are actually floods. So it's due to this excessive rain, right from those rain bands, or what's known as a storm surge. And a storm surge is actually what causes most of the damages to building structures and people. So the high winds from the storm blow large amounts of ocean water onto the coast. So as you can see from the picture here, wind is coming from the ocean and pushing and pulling water with it. Because of this, there's extreme floods that happen near the homes on the coast, and this is where a lot of the deaths occur and a lot of the structure damages happen. So just talking about some statistics on hurricanes and kind of their general size and things. The average height is actually 10 miles. So this is a very thick, dense storm that is occurring. Now going across the entire storm and how many clouds in its diameter. So the diameter, again, is going all the way across the big circle. The average diameter is 300 miles. To kind of give you a perspective of what this is like and how large the storm cloud is take the Empire State Building, which is 0.2 miles, and this actually creates, it's a little more than 0.2, but it ends up creating 1,000 Empire State Buildings if you were to lay them across an entire hurricane. That's how large the average hurricane is. So really just huge, huge storms that are occurring. And this is why they can be the most damaging and destructive storms that we've talked about so far. The classification and how these storms are categorized are based on the Saffir-Simpson hurricane wind scale. So again, these are classified based on wind speeds and how fast they are moving. And this is based on kind of the destruction level that happens at these different numbers of wind speeds. So I suggest that you just pause this video and just kind of take a moment to look at the 5 different categories and how they're classified. The next thing we're going to talk about is hurricane seasons. So based on where you are is going to impact the different conditions that hurricanes are created, right? Remember, we want these warm, moist air, and we want nice, unstable conditions that help create these storms. So if you're in the Atlantic, which is where we are, it is typically hurricane season is from June 1st to November 30th. If you are on the East Pacific side, that's going to be your California kind of west coast for the United States. It's going to be your mid-May to November. If you're on the Northwestern Pacific, that's going to be like Japan, Malaysia, China, and all that. That typically happens year-round just because of the different conditions that it's created. Your Southwestern Pacific, that's again your bottom half of Japan, Korea even, and Malaysia. It's going to be November to April. Your northern Indian Ocean, so that's near India, and the one coast of Africa is going to be April to December, and your southern Indian Ocean is going to be the bottom half of Africa, and it's going to be October to May. Typically, these hurricane storms usually occur over a week's worth of time. So that means that the storm over a certain city or state even or country will last typically about a week before it actually moves or dissipates out of the way. So huge storms lasting a very, very long time can create a lot of damage and deaths over a country or state or anything like that. So very interesting. So now that you have time or have had time to kind of digest all of this and understand, I want you to look at a video that I have posted to kind of help you, again, reiterate all of the things that I've talked about. And then you are going to do a GimKit online to kind of quiz yourself to see how much you have understood from this PowerPoint. Thanks, guys.